Now we are going to know about the mechanism of micelle formation. For micelle formation, take an example of soap solution. What is a soap? The sodium or potassium salt of higher fatty acid is called soap. Generally, it is represented as RCOONA. For example, sodium stearate is one of the example of soap. The formula is C17H35COONA. When soap dissolved in water, it dissociated into two parts, that is two ions. C17H35COO minus ion, that is called stearate ion, and Na plus ion, that is called sodium ion. The anion stearate ion consists of further two parts, that is the hydrocarbon part, that is CH3, CH2, CH2, CH2. This is a hydrocarbon part. Here we have 16 carbons. The 17th one is 17 carbons. Another one CO, C double bond O minus, and Na plus ion. Up to this is called hydrocarbon part. This hydrocarbon part is non-polar in nature. This is also called as non-polar tail. It is hydrophobic. Hydrophobic means water repelling agent. And the COO minus ion Na plus, this is called polar head. It is hydrophobic, that is water loving. When soap is dissolved in water, the RCOO minus ions, called that is stearate ions, present on the surface of the water with COO minus ion group in water. This is COO minus ion is in water, and the hydrocarbon chain, that is hydrophobic part, staying away from the COO minus. COO minus. At critical micelle concentration, the COO minus ions are pulled into the bulk of soap, or stearate ions. All stearate ions pulled into bulk of soap water and aggregated to form a spherical shape. In spherical shape, the hydrocarbon chain, that is non-polar part, pointing towards the center of the sphere, and COO minus ions remaining outward on the surface of the sphere. This aggregated form is known as ionic micelle. This is ionic micelle. At low concentration, the COO minus ions are in water, and hydrocarbon part away from the COO minus, that is on the surface, away from the surface. At critical micelle concentration, the aggregation of stearate ions takes place. In that, they form a spherical form. In spherical, the hydrocarbon part is inside the spherical, and that is hydrophobic, and the COO minus ions, that is hydrophilic, is away from the spherical. The aggregated stearate ions is called ionic micelle. Nearly 100 or more than 100 stearate ions aggregate to form micelle. So the aggregated form is known as ionic micelle. Next, we are going to know about the cleansing action of soap. If now we take a tub, and take soap solution in a tub. Usually the stearate ions are at the surface of the water. Now we sink the clothes with oil or grease, dirty, that is oil or grease having clothes are dipped in soap water. Then the soap molecules form micelle around the oil or grease droplets. The hydrophobic part of stearate ion is inside the oil droplet, and hydrophilic part projected outside the oil or grease like bristles. The polar group, this is the polar group form micelle. The polar group can interact with water. The oil droplets surrounded by stearate ion is now pulled into the water and is removed from dirty surface. Here, soaps help in emulsification and washing of oils and fats. What is emulsification? Emulsion means oil in water or water in oil. Liquid colloid is called emulsion. The emulsions are not stable. To stabilize